The talk today is about hand tools. I'm going to go over a couple things and start with the scrolling wrench. But as I go forward, keep in mind that any of the specific tools I am going to describe to you, they could be modified to make what you need for whatever your particular requirement is for your project. So we'll start with the scrolling wrench, and you see a scrolling wrench, actually two scrolling wrenches here, and one is in the post vise, tines up, and the other one is here in use, and together they are assisting in making this scroll. The scrolling wrench isn't limited to scrolls. It can also be used anytime you want to bend something. You can use two scrolling wrenches by holding a straight piece in the post vise and bend something just as easily as you can do something like you see here. So the scrolling wrench is made with mild steel, and we can case harden that to get a little more life out of it, but it's not something that you're going to be hitting, so mild steel and case hardening should be sufficient. For this demonstration purpose, I'm going to use the 3/8 by 1 inch flat bar. It's a good material to have around. It's something you would use to make the scrolling tongs. You could also, however, use other sizes. In fact, getting ready for this talk, I made a bunch of scrolling wrenches. I need to refresh my tool chest anyway, and I found that the longer size, 1 1/4 inch, really needed to be done with 1/2 by 1 inch flat bar. So that'll probably be the next tool I make. The most common sizes, and by size, I'm talking about the gap here. This gap. So the common sizes are 1/2 inch, 3/4 inch, and 1 1/4 inch. And you're going to see those sizes again. So don't worry if you didn't catch all those just yet. The tines are 1 inch tall and can be of various shapes depending on what your needs are. I'm going to talk you through this Chisel Point tines, but you could also have cone tines, and this might be helpful if you're bending something that has, maybe like leaf work or something where you have a smaller area that you want to get in and bend something. This is going to be 3/8 inch wide and might not be as amenable to a tighter spot. But the Chisel Point, I find, works well for just about any bending that I've needed to do. The key point here is, though, that these edges, these inside edges, need to be softened. If they're not, and they're left very sharp or square, you will gall your work, because remember, the work is going to be hot when you're bending it. So the softer this edge, the less disruption you will have to that tool that you're working, or the metal that you're working on. So our goal is to end up with something that looks like this and have our tines line up evenly enough to file them into the right size. We're going to start by laying on our 3/8 by 1 inch bar about 1 inch, and set that initial shoulder over a rounded edge. As you do this, you're going to draw this out to a 1/2 inch square, and be sure to chamfer those corners. Anytime you're working with something that's square, softening those corners as you work helps you keep a good eye on how straight your piece is. Helps you see the high spots. The goal here is to get a half inch on all four sides. That means it'll be a little wider than the 3/8 that you're starting with. Next step is to move to the off side of the anvil and lay off about, well, it should be a strong 1 inch. You want it to be an inch, but remember those rounded corners. You started up here with this shoulder and it ended up over here. So push this out at least 1/8 of an inch past that, or maybe even a little more, no more than 1 1/4, so that you end up with a good 1 inch pillow here. Go ahead and set that shoulder down, and then you can start to draw out what will become your handle, taking that down to the same size you did here, that 1/2 inch. So I have a video to watch that in motion. So we're laying on that initial 1 inch, keeping everything square, chamfer those edges, and keeping that just a little bigger than the parent stock. Start your pillow on the off side and then draw down your handle. Anytime you're drawing down big material, moving to the Bic is a good idea. It'll move a little faster. So there we have the start of our scrolling tongs with a square on the end, a pillow, and the handle is started. Next, you're going to take that piece that you just forged and you're going to put the short end down in a tool like this. And this is simply just angle iron with a backing plate welded to it. You can see a little bit of the weld there. This apparatus placed in your post vise gives you a stable surface and keeps you from galling this backside of your tool as you draw this pillow out into a 1 inch long taper. You're going to do that by using a fuller, and the fuller needs to be at a fairly steep angle. If the fuller is at too shallow an angle, you're going to end up just drawing the material back this way instead of drawing this material down and out. So you want to make sure that that fuller is as upright as possible. You'll initially get in there, grab it, but then you want to start pulling it down. Once you've started pulling it down, and you can see here that's been started, using a cross peen hammer to start to smooth that out will help it on its way. As you push this material down and get started on drawing this out to a taper, it's going to grow in width. It's going to get thick. It's important to dress that thickness frequently. And when you do that, which, I mean, that's just as simple, you're hitting this here to correct this growth in width and get it at least back to the parent stock. This bar right here that you've started is going to bend to less than 90 degrees, like so. This has gone to a narrower angle than 90 degrees. When that happens, when you put this part back down in your angle iron with the backing plate on the post vise, you could end up with a little gap here. As you continue to squish this material down, that air gap is going to create a cold shunt. It's going to create a crack that will make you very sad later. So it's very important that you make sure this is kept at a 90-degree angle. The easiest way to achieve that is by putting the tine, or on its way to becoming a tine, up in the post vise, and this is a set tool that you will hit with your hammer to straighten this back out. Then it's just a matter of going through those 3 steps. Back to your backing plate with your fuller and your cross peen, correct for the growth and width. Make sure this is at a greater than 90-degree angle using a set tool. I suppose you could hold this flat on the anvil and hit it, you know, do kind of like that upsetting blow, hit it back, but you do run the risk of landing a blow somewhere else. So putting this in the post vise with the tying up and using a set tool is your best bet. And then it's just a matter of going through those steps till you have this should be about a 1/2 inch wide, and this will be 1 inch wide. And of course you want this to match that parent bar at about 3/8 of an inch. So let's watch that happening on a video. Get a really good view of this backing plate situation here too. So grabbing this material and pushing it down using a fuller, and this is a very narrow fuller. Correcting for the growth and width. And then right back to your backing plate and your post vise and continue to work that down. You can just see this leg kick up as you correct that growth and width. So it's time to open that back up. And here's the set tool, opening that back up in the post vise. So, you know, a handful of heats, going through all those steps several times. Correcting for that width early and often is going to be important. So once you have your tine the way you want it, it's time to cut this off to the correct length. And I'm going to give you the answers if you and I'll give them again later too on a chart, so don't feel like you have to write this down if you're taking notes. So if you want a gap of 3/4, the total length that you need is 1 1/4 inches. And I know that because using these 3 measurements, I can add them up and I can get to my 1 3/4 inches. The W is the gap, the desired gap or width that I want. And in this case, it's this 3/4. The bend is roughly the same amount of material as you have width here. So that's a 1/2 inch. And then your height is cut in half because when you make this chisel taper, you are cutting the material in half. It's going to stretch 2 times. You can almost see that if this was its full length, that this is in half right here. You can see the imaginary half that I'm outlining with my laser pointer. So 1/2 of 1 inch, which is the height, 1 inch, plus 1/2 plus 3/4 gets me to 1 3/4 inches. So I cut that off. I'm going to cut that off on the edge of the anvil. And here it's been done conveniently with the tying up. And that gives you plenty of room to move to the side of the anvil. If you want to have this with the tying down, I would cut it at a slight angle so that you're set up for your next step, which is to make a taper. And what you're seeing here is that here's the tine out, stretching out away from us. it's also, it's on its side to remove some material, because we know when we make our point, it's gonna grow in width. So if you get ahead of the material, remove some of the excess, you can then place this either upside down on the far end of the anvil, over a swedge block in the hardy hole, or here just on the edge with the tying down and getting your taper started here. You just want to make sure you're not dinging up your hardy hole when you do that. But you're going to make a point, a chisel point, which is just a wide point. And anytime you're making a taper, which means you're making a point, you got to get to the point. Make the point first. So a very short point right on the edge. And here it's being done over just a block, a swedge block. So here you see a very shallow point, chisel point, and now you can taper that back to the 1 inch length that'll match this time. And here's the photo depicting that with the correct angle on your hammer, and this over an edge. Anytime you're trying to create a taper like this, if you do it in the middle of the anvil, your hammer really has no place to go. It should be angled, and you can see that if this didn't have a hole or a space to go into, you wouldn't even hit your piece. You would just hit whatever your hammer was over. So that's one way to really ding up your anvil. This is your best chance to soften the insides. So we have our 1 inch taper here set, and just turning it up, and you could do this hot with the rasp, turning it up, tying up in the post vise, rasp off both sides, including this tying as well. So now we get to watch that all happen on a video. So we're cutting it off, a nice straight edge, which gives you a nice clean spot to start with. Remove the excess material, because you know it's going to grow in width as you make that point, which get right to the point. Then take it back to your 1 inch, which is our desired tying width length. Be sure to file it. You're going to want to move on to the next step. So make sure you remember that this filing, this is the best time to do it, unless you've got a whole drawer full of much, much smaller files. So using the rasp, this is the best time to do that. Now we are ready to bend this around to even up with the neighbor here. And to do that, we are going to bend it around the horn, but this part, we don't want that to bend. In fact, we don't want it mucked with at all. So the best way to keep that from happening is to quench it. We're using mild steel. There's no repercussions for that. So make sure that you're only putting it down that 1 inch, which, your line of sight is pretty clear here, the edge of this taper, maybe just a little past, leaving enough hot for the corner material and then the gap that you want. Once you've quenched this, move quickly to the bick and bend this around. When you're bending, anytime you're bending, you want to do it over, I always say over air. If you're here in the anvil, it means you're forging and you're hitting or squishing your iron in between this hard surface and your hammer. So with bending, always make sure you're over nothing. As you bend this, it's gonna kind of push into your gap, and it's gonna bend up here too. So correcting here and bending, just keep your eye on this to make sure this part stays straight. What you don't want to do is bend this closed to 90 degrees. You want to keep this open a little bit, because using the method you would use to make square corners, you're going to upset this back into itself and give you a little more material here in the corner. So with this tines up on the anvil, and you might need to take another heat at this point. If you do that, re-quench this tip. It's going to be important that you're not deforming this. You're going to end up with a little mushrooming, which you see here, and mushrooming is just anytime you hit the top of the metal and it starts kind of leaking over the sides. That's called mushrooming. So with this quenched, this hot, you're going to hit on an angle. If you were to hit straight up and down, this would just roll out and kind of defeat the whole purpose of the bend you just made. So you want this at an angle, kind of matching this angle. But one way to think about it is you're hitting down towards your knees. Smith is over here, hammer is angled, and you're hitting towards your knees, which is a little different blow than you normally do. Once you've got that upset back into itself and you have your corner here, and it's not going to be a completely square corner, you'll have this round edge here, but you have this, then you are ready to heat this all up and put it handle down in your post vise. And here we're using our backing plate again. This is the same angle iron and backing plate we used earlier. And this time we're taking a bar of whatever size the gap is supposed to be. In this case, I think I said we were making a 3/8 inch gap. So you'd get a 3/8 inch bar and round the edges, because we don't want to gall up the inside of our tool, and hit it once from this direction. And you can see that makes it stand up, and pay attention. Once you've got it standing up straight up against the backing plate, now you can tap it down here so that you have your 3/4 of an inch gap, or whatever gap it is you are trying to make. So let's watch that happen. We've quenched the tip, and there it is. You can see this goes up, and you just got to keep it straight, working the bend, working that back the way it started. You can see the tine is considerably longer at this point, so that angled blow back towards your knee upsets this down into the corner. And you might have to take more than one heat. Definitely had to for this tool here. And then that's just a light tap to get it into place. Make sure everything stayed straight. Sometimes it might get a little twisty. And now you're ready to file off any of the mushrooming that happened, or if this is a little bit longer than the other side, you can even things up with the rasp. And you would again do that hot. So this, once this is made, draw out the rest of your handle, and I like to take it to about 12 inches. I brought some with me here, so maybe if we ask questions or at the end, I can show you those. I like it to be about 12 inches long, and then at the end you could put whatever handle you want, but an eyelet is a nice feature because now you can hang it up out of the way. And that's just a matter of drawing out a rod to a 3/16 diameter, and it should be fairly even all the way around, and bending this then around into the correct shape. But if you are wanting to be specific about what this internal diameter is, you need to know how long you need to cut this. So here comes some math. If we want a specific internal diameter of 5/8, we would use this formula, because what we're looking for is the circumference. We're looking for how long this piece needs to be. And that's a simple formula of pi, which we know is 3.14, blah, 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 and the diameter, this blue bar here. And you may be asking, why am I going all the way out to this yellow line? Well, this yellow line is something called the neutral axis. And it's called the neutral axis because that's the only part of this rod that doesn't change its length as you bend it around the horn. The outside metal has a longer distance to go, so actually ends up stretching but shrinking this tip right here. This actually gets shorter than what you started with. The inside gets compressed, and that metal has to go somewhere. It'll pooch out to the side, plus make that end longer. If you saw the basket handle talk, I explain it there with some different diagrams. But for our purposes here, you just need to know that this neutral axis is the start and end of the diameter that we need to fill in the formula. And here I've filled it all in for you and nicely color coded it. So this little bit here, this 3/32 and 3/32, which is half of our 3/16 bar, and 2 halves make a whole. So you just add the 3/16 back in, plus the middle, which we dictated, was going to be 5/8. And you'll notice that I'm only using 3 here. That 0.14 for pi, true pi, adds about 1/7. And, you know, we're not machinists, we're blacksmiths, so we're not going to worry about that. We're gonna make that part simplified because it's close enough. And we're just going to take the 3 times the 3/16, and that gets you to the answer that I already gave you, which was 2 7/16. But while we're here, let's do a little more math, because how did I know that I needed to start with 1 inch to get those times to line up right? The trick is to make sure that you have enough material so that you can cut off a clean end. What you don't want is to get to the point where you're cutting off that 1 3/4 and you don't have 1 3/4. You'll be tempted at that point to draw that bar out. That, remember, it was a 1/2 by 1/2 square at that point. You'll be tempted to draw it out, which is going to make it kind of weedy. We want to leave as much material there as possible. So it's important to know what amount you need to start with to get the right amount here. Now you could just hedge your bets and start way back here and make a nice long taper and then cut off your 1 3/4. And that's an acceptable practice. But if you want to take your blacksmithing to the next level, understanding a simple concept that allows you to do the computation to get to the right answer is going to be extremely helpful. It'll also really impress your friends. And, you know, I told you that you need to lay off the 1 inch, and you could just do that. And I'm going to tell you how much to lay off for all the different sizes. But I don't know. I like knowing for myself. I don't like just being told what to do. So I'm going to take you through the math here so you can do this for yourself and impress your friends. The first concept I want to discuss when we talk about this is that this amount, when we're back to 1 inch, and this amount, when the gap is 3/4, is the same volume. If this was a piece of clay and you stretched it out and made it into a different shape, you didn't change the amount of clay, you just changed the shape. So what we're talking about is setting two volumes, this volume and this volume, equal each other. And the volume formula for anything that's a straight edge is fairly straightforward. It's the height times the width times the length. Another way to measure volume is to have something with a bunch of measurement marks on it filled with water, and you would put your metal down in here. Here you can see the metal down in here, and you can see that this changed from this line to this line. This amount of water was displaced by the volume of your piece. So you could take how much you want to have as your goal, put that in some water, note what the water level gets to, and then take your starting piece, put that in the water, and when it gets to that same water level, you've displaced the same volume. And then you'll know how much to lay on at that point, or how much material you need. I'm going to suggest that we do this with numbers and just set these two measurements equal each other. So here we're back. We know what our goal is, and we know that we want this to be 3/8 wide by 1 inch tall, or half inch tall. And the length is the only thing in dispute, depending on what your gap is. And over here, we know that we're starting with 3/8 wide by 1 inch height, and we need to know what our length is. So I'm going to call this the length goal and the length start. That's what the LS and the LG is about. So let's start with our goal length, because we got to know where you're going, or you're not going to get there, right? You saw this already with the width of the gap, the bend, which is the width of our material, and then half our height, which we know is 1 inch. We're going to put the number to that, and in this case, I'm going to use 1/2 of an inch. That's going to be our width, and I know that I want from here to here to be 1.5 inches. So now I can fill in this part of my formula, and now it's just a matter of solving for the length that we need to start with. But if I know that from here to here is 1.5 inches, you could kind of do a visual test of if I'm starting 3/8, I've got 3/8 and 3/8, so I don't have to worry about those. Those are going to end up the same. But here I'm going to take this to half the size of this 1 inch to start with. So I could just cut this in half, because I'm starting with 1 inch, and if I take that down to a 1/2 inch, it's going to stretch out, meaning I just need to have half the 1.5 to start with, which is 3/4. So we kind of know that our answer is 3/4. So let's see if the math bears that out as well. So anytime you're, now we got some simple algebra going on. We've got two equations equal each other. We want to isolate for our variable, meaning I'm going to times all these together. I'm going to times this together, and then divide it into here, which for a fraction means you turn it upside down, and solve for the length to start. And there it is, it's 3/4. So if we do the math for all three sizes that I mentioned a 1/2 inch, a 3/4 inch, and a 1 1/4 inch gap size. The length, once we have our initial tine, is 1 1/2, 1 3/4 for the 3/4, and then 2 1/4 for the 1 1/4. And I know my lengths to start. But since we're using that rounded edge, I'm going to add a little bit, because remember, my goal is to end up with a little more material than I actually need. So it never hurts to pad it at this point just a little bit. So we're going to add 1/8 of an inch, and here's your lengths to start. And if we go back to our 3/4 inch gap, there's your 1 inch. So how are we doing? Anybody have any questions? Or if I don't see Greg's face pop up, I'll assume no. Now he's talking, but I don't.
We seem to be doing pretty good. I'm not seeing any questions.
All right.
Yeah, we can continue on.
We can sally forth.
There we go.
Okay, great. So now it's just a matter of finishing up your handle to that 12 inches long, because remember, that's where we left off before I went off on the math situation. And keep that about 1/2 by 3/8. Make sure you chamfer all your edges. It is a tool you're going to hold in your hand. And now we're going to lay off 5/8 of an inch. And that same volume formula applies here. We want to draw this out to a 2 7/16 inch length, 3 1/16 inch wide rod. And if you start with 5/8, you'll get exactly the right amount. Start first by setting a shoulder on one side, and then correct. Here it is, the shoulder. This is what was face down. Correct for the width here. Bring it back to the side of the anvil, and you could use a guillotine tool at this point, but you want to bring in the shoulder on each side. It's not very much, so this is a really good chance to practice your hammer control. Just hit from both sides. So, a couple hits here, turn this over, a couple hits on the other side, because you want to keep this in the middle. And then it's a matter of drawing this out so that it's 3/16. Start wide. So start, anytime you're going to take something to round, you start with the square. You can go over the horn to draw it out. And once you've got your square drawn out, and I would make that a little wider than 3/16, because as you take it to octagon and then to round, it's going to continue to stretch in length and get a little smaller. So once you have the prescribed width, now you can cut it off to your 2 7/16 material. And if you put this down and protect the shoulder, this is going to automatically, just because of the lack of resistance from this little nubbin here, it's going to create a slight taper on the end. And that slight taper is going to tuck in nicely to the side of the eyelet when it meets, when it turns round and meets the other side. Oh, here you're 2 and 7/16 inches. I've said it several times, but I want to make sure you have that information. Now you're ready to turn the handle over, and you're going to bring this out as far as this is wide, which is 3/16, and start to bend it. Use a cross peen or even a small ball peen hammer to start the bend. And as always, you want to be over air to get that going. And once it's about 120-degree angle, dress this and make it look all nice. When you're dressing it, make sure you're not galling the underside. So very gentle taps, and make sure this is hot enough. Once it's bent and dressed, bend your ends. Bend this end and then the tip, because those will be harder to fix later. Get them to the 5/8 round. Get that started, and then it's just a matter of bending it over the horn. And as always, when you're bending, not forging, you're going to take this straight down, lower the hand that's holding the material, and it'll just snug up nicely around. And you can see that our little slant here, our little taper, tucks in nicely to the end. All right, so let's watch that happen. We're cutting it off to whatever length you want your end handle to be, and drawing the handle down the rest of the way. And now we're measuring out to draw out our eye at the end of the handle. So you set the shoulder on 3 sides, and then it's just a matter of drawing that out until it's 3/16 wide. You start with square, go to octagon, and then make it round. And anytime you're rounding, you never want to hit the same spot twice. Cut it off at the 2 and 7/16. Get you the nice little taper at the end. Bend it to that 120 degrees. And then start your curling or bending around the anvil, and then hitting over air. You should not hear the anvils ring at all. Moving the material hand, and you can get that snugged up there nicely. Anytime you go to a circle, you don't want to hit the same spot twice. Notice how softly those hits are anytime you're over something hard. So that'll get you your nice little eyelet. And you want to make sure it might get a little crooked in there, so you'll want to make sure it's centered up. So now you can take your tine end and case harden it. Case hardening is like adding kind of a hard outer shell, a lot like an M&M candy. The whole goal here is to help your tool last just a little bit longer. This isn't, I'm not doing a class on like metallurgy or getting into the details of this, but essentially you're just going to follow the directions on the jar, which is heat your piece to the 650 degrees and apply the carbon and flux, which is what this material is. This is gonna smoke a lot. This is not something you want to breathe in. I kind of stand out of the way. It'll be a very obvious plume of stuff you shouldn't breathe in. So make sure you're not breathing that in. I'll wear a mask sometimes too. So apply your compound while it's hot, reheat it, and you can reapply and reheat if you want a deeper hardening. But when it looks wet, when you've got that back up to its cherry red color, when it looks wet, you're going to quench it quickly in some water, and you should hear a loud pop. It's like you're turning the carbon to gas to get it in there to permeate and create that hard outer shell. And if it doesn't make a loud pop, or you don't think things went well, just do it again. It's something that you could do a couple times. So that is our scrolling wrench, sometimes called a dog wrench. Any questions?